Hi folks, welcome back. Now we have a good understanding of data cube, and we learned that the full materialization of data cube is very costly. Now in this part, we are going to learn two different ways of creating data cubes or different ways of creating actually the data cuboids. The first way is multi-way array aggregation, which is actually a full cube computation that we go from the base case to the top case. For each of the base case, we are going to aggregate our data with one dimension. And for each of the upper level of data cuboid, we are going to choose one existing dimension and we aggregate them. So that is the multi-way array aggregation. So this one is based on a top to the bottom algorithm, and it provides multi-dimensional chunks of data, and we can do that at the same time. And because we can do that at the same time, it actually can save a little bit of the effort on database scanning if we are going to operate that on multiple dimensions. And the cons for this algorithm is, of course, it is costly. It is not scalable, and also it cannot do a priori pruning. We cannot stop when we meet a certain threshold, and we cannot just proceed if we meet some certain threshold. And of course, it cannot do for high dimensions because, again, it is not scalable. The full cube computation is always not an efficient way to do so. So this is a picture of how we can do the multi-way array aggregation simultaneously. So think about, we have this data cube has 3 dimensions, and each of them only has 3 possible values, which is very small. And in terms of aggregating the 3D objects into 3 2D objects, we can actually just go from this cell and aggregate for this layer, and aggregate for this layer, and aggregate for this layer as well. So for each of the layer, we can see for this projection here, we are aggregating the bottom layer to this one. So we are discarding basically the B dimension. And for this picture, we are projecting our cube into this 2D, and we can aggregate them into this place, which is, I believe, this cube, this slice of the cube, etc. So you can run a very simple for loop, and you can summarize the needed cells into the aggregated dimension, and you can just run your database once, and you get every single dimension projection done. That is the multi-way array aggregation. And the other way is to counter the efficiency of the multi-way aggregation, that is the bottom-up aggregation. So the name actually is confusing. I totally understand that. The name is just be given by the authors. It is actually a top-down computation of iceberg cubes. So think about, we have the top ones, we just need to break it down into the data cube or data cuboids we need. So if we do not need those not used data cubes, we can just stop and we can just relax, so that we can save the effort in having all the data cubes that may not be useful. So in terms of the breaking down, for example, we can break the A1 into Bs, and we only break down B1 when we C1 and C2 is needed. And we only break down C2 when D1 and D2 is needed. For all other cuboids or for other data cubes, we can simply just keep them as a aggregated or as a summary of the value. So we don't have to do them, which saves the effort. Okay, so And this is just a very introductory conceptual thing about data cube and data warehousing. So this module is definitely not to introduce you every details. The data warehouse itself can be a semester-long courses. So if you are happy about those topics and if you want to have some details of this data warehousing and data cube, there are more readings I'm recommending you to go and find out. The first one is by Amazon, that is Data Warehouse Concepts. The second one is by Oracle, that is Database Topics, Data Warehouse Topics. And the third one is by IBM, that is Data Warehouse. And the last one is by Google, that is Data Warehouse Explained. And those links are, you can click those links to the details and you can explore the information you like. Okay, that will be our end of the module, and congratulations, you finished this module data warehouse. You have a better understanding about the data around us now. You learned one perspective, that is you have a transactional perspective or operational database operational perspective, then you can choose OLTP for transaction processing. If you have a decision supporting or decision making or analytical perspective, then you can choose the OLAP. Okay, next question will be, if you just have tons of data, but you at this moment you have no specific perspective, or if you don't have a certain interest or certain subject to build a data warehouse, what do you need to do? The answer might be big data. So we are going to introduce you in module 3, and I'll see you there. Bye.